Hello, it's Cliff here from Down Under. In this video I'm going to talk about work holding using super glue or instant glue and masking tape, and I'll be doing some tests to try and get to the bottom of it. Do you need to use expensive masking tape and super glue, or can you get away with budget masking tape and super glue, and how well does it hold? I'll actually be doing some tests and doing an example of machining a whole lot of these cover plates for the Hallmark lathe tool setter on a big grid on a base plate, and going through all the different stages from the beginning to sending them off for anodizing, and what I've learned along the way about work holding with super glue and masking tape. Cheers. Well, I want to machine some very thin aluminium parts and use the adhesive method with a double-sided sticky tape or the super glue on masking tape system, and I've done this before and it works really well, but I thought I'd just update myself on all the information on YouTube. So I sat down for half an hour and watched half a dozen different videos on the subject, and that you get different takes on different ways to do it. Some promote using double-sided sticky tape, some promote using 2 layers of duct tape, some one, some activator, some cleaning with acetone, some cleaning with isopropyl alcohol. And I wonder, well, some promote burnishing the masking tape down with different tools and how important it is to do this and do that. And I wonder, well, has any of this been scientifically tested, or is it all just a gut instinct of what we've tried and what works? The trouble is with just promoting what you've tried and what works is that there may be a lot of misnomers in there. There may be unnecessary steps. So I thought, well, how do I know which is the simplest, best way to do it? So I've just done a little test, and I thought, well, I'll minimize down the number of steps to the absolute minimum. It's the only way I'm going to really know what is important and what isn't. So I just use ordinary green painter's masking tape. This is Norton masking tape. I just wiped it with methylated spirits, not isopropyl alcohol or acetone, so it's getting a very basic clean. Put the masking tape on, rubbed it on with my finger, not fully burnishing it down. Wipe that surface with methylated spirits on a tissue, put on a little super glue and stuck it together. It sticks really well. Now, how does it go with coolant? People talk about mist coolant, but what about immersion coolant? I want to use flood coolant. I don't know whether it's going to come off or not. So I'll put it in some coolant, half in and half out, and I'll soak it for a couple of hours and simulate whether or not it's a problem. So I'm trying to get to the bottom of what is the minimum required to get the maximum results. Well, it doesn't look like the cutting oil is going to be a problem. I've had it soaking for about 3 hours now and checked it every hour or so. This is a semi-synthetic cutting oil, so it's got an oil soap base as well as a synthetic base, and there's no obvious lifting of that area significantly anyway, and it's more exposed there than between the aluminium. So given that the average job's only going to be in the machine for half an hour or so at the most, I don't think there'll be a problem with cutting oil. Alright, well, let's carry on with this scientific test. So let's see how well stuck on that is. Very interesting. Okay, so the first time I glued it on, I used super glue and just cleaned the surfaces with methylated spirits. And this super glue is just a cheap Chinese $2 shop pack of 10 or something. And what happened was it split away off the masking tape. So the masking tape adhesive was stronger than the super glue, and the masking tape stayed on. So what I did then was I cleaned it with acetone, and I got some higher grade super glue. This is a Loctite Professional. Doesn't seem to have a number now, but that's it there. And left it on overnight. Just tested it then. Well, you saw that it's pulled away, it's taken off the masking tape adhesive. So now we've presumably got a more powerful adhesive from the super glue than the masking tape. That's pretty conclusive evidence that either cleaning with acetone or the higher grade glue helps, is better than cleaning with methylated spirits and using the cheap super glue. So in future I will clean with acetone and use the higher grade glue. But of course I didn't measure with a spring tension how much force it was, but it didn't seem a lot better. So the cheap solvent cleaning with methylated spirits and the cheap super glue felt almost as strong and probably would have been perfectly adequate for the job. But that's interesting, a little bit of information there. So I'm just making up this base plate out of a bit of scrap aluminium. I would have liked a little bit thicker, but you know, I just had this offcut, made up some T-nuts and some 6mm caps which can be submerged down below the surface. I've installed it so the concave is to the top, so when I tighten these bolts it'll pull down flat, and then I'll take a very light skim cut to generate a flat smooth surface. Well, look at this, it's a big base plate, so I need quite a bit of X travel, and look at this. Overlapping machines. I love it. Alright, let's do some more scientific tests. So we've already, just to summarize, shown that the higher grade of instant glue, the Loctite Professional, with the higher grade of solvent, the acetone, does seem to produce a slightly better hold, although even the cheap instant glue with just methylated spirits is almost as good. Not quite in the same league with this breakaway test. So now we're going to test different grades of masking tape. So I've just got 3 different grades and I've sort of really pressed it down. You can see when you put the pressure on it, it really changes color and really merges into the surface of the work. So over this end we've got bare tape, general purpose, that light colored, that's the cheapest one. That's about $2 for a 36mm wide roll. We're talking US dollars. The middle one is bare masking tape Painter's Edge Pro Green. That's about $6 US for a 35mm roll, 36mm roll. And finally we've got 3M extra strength painter's tape. Now that's a bit thicker. You can see for the same length roll there's quite a bit more depth there. It's about 0.14 thick as against 0.1 thick. So let's do a bit of a measurement now and just see how much stronger it is. So I'm going to come up at an angle of about this angle and see how long it takes to tear loose. So put some weight on it, 5 kilos, 7 kilos. I'm lifting it up to about 20 degrees, 12 kilos, and it's tearing away and broken at about 12 kilos. Now we're going to use the Painter's Edge Pro Green. Oh, it just came unstuck on there. Alright, won't waste your time on that. I tested it before I did this on camera test and it was about the same as the general purpose one. Now let's test the extra strength, the 3M extra strength painter's tape, about the same angle, 10 kilos, 15 kilos, it's tearing off now, not even breaking. So that's quite a bit stronger, and it seems to be a stronger adhesive and a stronger tape. So I would say that if you're just holding down thin parts and using small cutters, small drills and things, the general purpose or the Pro Green painter's tape would be adequate. It's not quite, it doesn't hold quite as well, but if the part's not highly stressed, that would be fine. But it wouldn't hurt to have a roll of this 3M extra strength painter's tape when you've got a high stress application, where you've got a thick part or a big cutter and you really want to optimize the holding. So a combination of that and a good quality instant glue and cleaning it with acetone is going to give you the best chance of holding really firmly. Some of you might be thinking, but you haven't tested it with an activator and without an activator. Well, I don't really need to do that test, because I read in a couple of different places and on the Loctite website that an activator only speeds up the curing. It doesn't increase the strength of the curing. In fact, it slightly weakens the strength of the curing. And seeing how rapidly it set in my first test, I realized that adhering aluminium or probably steel onto masking tape sets off very fast, and using an activator is only for borderline situations where you're having trouble with it setting off, and then you are slightly weakening it anyway, so there's no need for me to test it with and without an activator. Clarify those prices again. So I'm sort of roughly working it out, converting from New Zealand dollars and guesstimating it on the basis of width. So this is pretty approximate. The general purpose one's probably about $3 for the bare general purpose masking tape. The Painter's Edge Pro Green bare masking tape is probably about $6 for a 36mm wide 50m roll. And the high strength, extra strength painter's tape Scotch rough surface 2060 is probably about $12 a roll. That's quite expensive. So you would only want to use that in a high stressed application. Alright, for the purposes of this test, I'm just going to use the medium priced Painter's Pro Green masking tape, because it's not a high stressed application. And how am I going to know if I don't test something that's below par whether I've got an unnecessary holding power? Okay, so we'll put this on, just burnish that down and clean it with a bit of acetone, the top surface. I don't really need to clean the metal parts because I've sandpapered those with 240 grit wet and dry paper dry to actually cut into the surface, so it's got a nice contact grippy surface. I don't really need to clean those with a solvent, but I will clean the top surface of the masking tape. Okay, so I'm just burnishing it down. You can probably see from there, oh, wrong end. You can probably see from there that it really presses it down, sort of changes colour. So I imagine that's merging the rubber-based adhesive fully into the metal surface. That's really worth doing. And then I suppose the solvent helps to remove any waxiness. You know, because in the application of a painter's masking tape or a spray painter's masking tape, it doesn't matter if it doesn't stick very well to the back of the tape. In fact, it probably intentionally is not meant to stick well to the back of the tape, so it can peel off. So it may have a waxy surface on it already, which is not ideal for this situation. We want it to stick pretty well. I put a little parallel on the end that I hopefully can roll around when I finish machining to help me peel it off. We'll see how that works when I've done the machining. Alright, I'll clean that with some acetone now and then put the Loctite on. Alright, bit of acetone. Maybe that's helping to take off some of the waxy surface. Yeah, I don't know. Somebody watching this knows about the chemical formulas of masking tape. Please comment below. So maybe that stripped off some of that waxy surface. Now I'm not sure how much to put down of this instant glue. So I'm just putting down a run about every 10 millimeters, about every 3/8 of an inch. I don't know, I'm just guessing at this. I want it to be even. I don't want to create too much thickness, which will then hold it up. It'll spread out when I put it down. Oh, nearly had an accident then. Alright, something like that. Well, how much have we used? Yeah, that's only used a tiny amount really. I've chosen the side of the plate which is high in the middle, so it will, let's get this reasonably even. So a bit of pressure will help in the middle. Sticky stuff. Alright, push it down, and in order to keep it down, I've got this big block of steel on the top. And if I was younger, I'd climb on top of it. No, I'm not going to do that. So that can stay on there. Hopefully that's pushed out any bubbles and high spots and curves in the aluminium. And leave it like that. It's probably gone off pretty quick, but I'm not going to be doing the machining till tomorrow anyway. This is a Sunday afternoon video special. Monday morning, I could start machining. So when I did the CAD cam, this is a 24 off grid. I also did a 1 off, because it's got various critical features like, you know, chamfer size and countersunk depth and so on. It's very easy to get that wrong, isn't it? And then I just got a rough piece of scrap and just machined that and tested the tools and measured the final result, because I don't want to produce, you know, have it machining for quite a period of time and produce a whole lot of substandard parts. So that's probably a worthwhile double check, is to make a 1 off first and then go to your production. I couldn't easily get any sheet aluminium at the right thickness, so I'm machining down a thicker piece. So I'm machining down this 6061 plate that I have that's 4 millimeters thick down to 1.7 thick. Just a note of caution, I'd be a bit worried about doing that with steel, because steel has a lot of stresses in it, and it could easily buckle up and put a huge force on the adhesive, and probably it could pop free or pop loose around the edges. But aluminium doesn't seem to have the same amount of stresses in it, and I'm hoping I'll get away with it. I just couldn't easily source some 1.6 or 1.7 thick aluminium without buying a full sheet and paying for the freight and on a big pallet and all of the drama that goes with that. Well, that's the first tool, the 4mm profiling tool. It went really well. Nothing came loose or had any disasters. You know, although I did the test with the coolant and that green tape, I was still a bit nervous that one of them would come loose, that it wasn't stuck properly, or that the coolant would get underneath. It's quite a long program running all of those 24 parts and having it machined down out of 4mm plate. I was quite nervous, but you know, it's all behaved according to the science tests. And so next, this could have been done obviously with laser cutting, but the next stage is chamfering and countersinking, and with Z moves, that's much better done obviously by CNC. And so it's really a CNC job because of that. So yeah, I was worried about the masking tape gumming up the end of the cutter into a little ball of goo and then causing a snap cutter or a shifted part. I'll press on now with the next couple of tool changes: drilling, chamfering and counterboring. Well, that's worked well. As I mentioned, you know, laser cutting doesn't give you the chamfers and the countersinks, and so that's the advantage of doing it this way. Looks the same as the test part, and nothing came loose. The super glue and the masking tape don't seem to have been affected by the cutting oil as per my earlier tests. I think I've done this type of work years ago using double-sided sticky tape, but I don't think I've ever done it with super glue and masking tape. So it's really good to test that out and record it for future use. Hope you guys can benefit from it. I was going to sand the top surface of the parts with a bit of wet and dry. It'd be really easy to do while they're all at the same level and they're held. But I quite like that surface finish, sort of a fly cut finish. So I might just leave it. It's an industrial product. I don't need to worry about getting it mirror finished. Let's just have a look at how well these parts are held on and getting them off. You can see me there, I think. Just pushing them. Yeah, you can sort of move them. Sort of they slowly. Yeah, I can see them moving a few thou just by pushing on them with this piece of plastic. But it may be just the springiness of the rubber. They're not actually coming loose. Alright, well let's see. You see me there? I've got a piece of parallel, a strip of parallel under it. So what happens if I just try and peel them off? Wow. Look at that. It's just torn the masking tape. I think the masking tape has been weakened by the coolant, at least where it's been able to be got at by the coolant, but it may not be weakened underneath the plates. So now I might try, I was hoping they'd just peel off, but now I might try a hot air gun and see whether that loosens it. Alright, let's just see what's involved in this. Put the hot air gun onto one part, see what happens. Of course, it's getting a lot of the heat sucked out of it. I've got a bit of plastic here. No, it's going to take a bit more heat than that, I think. So maybe I have to use a flame. Let's try a bit more serious heat on it. Wow. That's really stuck on there. Yeah, you see my problem. It's stuck too well. I don't know why I was worried about it coming off, because a lot of the heat's getting sucked out by the contact. Alright, I'll have to turn the video off and think of something else. Okay, a little bit of experimenting has enlightened me a bit, so I just have to live with a little mark on the corner, and then you can just, without even heating it up, peel it off. So that's okay. It's just a matter of getting a sharp screwdriver and using a bit of leverage, and it does seem to break it off remarkably easily. Now, I wish I'd gone a little bit deeper with the profiling cutter, because there's a little bit of a burr on the bottom edge, which I could tumble or hand fettle off. The reason why I didn't go deeper initially is that I didn't want the cutter to gum up with the adhesive and form a little ball of chips and gum and then break the cutter or wreck the job or shift the part. But you know, there's a burr there, and the only way I'm going to know whether this masking tape can be machined is to try going a bit deeper, you know, another 4 or 5 thou deeper, so I go through the masking tape and see whether that works, because it will produce a tidier part with less fettling to be done afterwards. Okay, well that all came off pretty easy, so I used just an ordinary screwdriver but sharpened it on the grinder so it had a nice sharp edge on it. And I noticed that lifting them off, about half of the tape stuck on one side and half on the base and half on the part. That means that the adhesive on the back of this particular type of just average quality green, pro green bare masking tape, the adhesive on the back of that, when it's burnished down, is just as good as that professional Loctite that's with the surface cleaned with acetone on the other side. So we've got equal there, and so there's no real need to use the more expensive thicker masking tape with a stronger adhesive, because then it's still limited by the strength of the Loctite. So that's a pretty good balanced way of doing it. So about half the masking tape stays behind and some stays on the back of the part, but you can scrape it off quite easily with a sharp screwdriver, because the Loctite is quite hard and it sort of shears off quite quickly and easily just with a sharp screwdriver. Okay, just a note regarding coolant, because I know some of you will be thinking, do I have to use mist coolant or can I use flood coolant? Well, my test showed that it didn't affect the masking tape much within a period of 3 hours. But this particular situation with flood coolant, I noticed around the edges where the masking tape was getting really saturated with the coolant that it was definitely softening up and not sticking as well. Whether that would penetrate underneath the parts where it's sort of sealed is another question. It may be that it would slowly penetrate there. So if you were doing it one day and leaving it overnight for another machining operation, I would say the safest thing would be to blow it off with compressed air and dry off the coolant so that it couldn't continue to penetrate in underneath, because it does slowly attack the masking tape, this semi-synthetic Synthol coolant anyway, but not enough to be a problem over you know, just one machining operation. If you want to set up your work offsets and your parts just got rough sawn edges, you can still save yourself a lot of time using a probe. Here, I'll see if I can do this. So if you put a little block in there, and let's see, find center. another little block in the front, just touching up on the sawn edge, and then the same on the X. Just saves you worrying about whether you've got it in the middle of the stock. So the probing routines with PathPilot are very useful. This is just one rough way of setting something that's quick and easy. So now we know we're in the middle of the piece of rough sawn stock. Okay, so I've just finished the other cover plates, the anvil side cover plates. And I've gone a little bit deeper with the Z, about 1/6 thou deeper, so it cuts through the masking tape and there's no burr left. I think that'll be better. It's a little bit more difficult to remove, and you get a bit of masking tape left behind, but that scrapes off quite easily because the instant glue is quite hard and easy to scrape. So I think overall it's better for me to go a little bit deeper and just resurface my base plate by a couple of thou each time. And so you can see there I've cut right through it, and it doesn't seem to have clogged. Doesn't seem to have clogged the tool. So obviously the tool with the flood coolant can cut through the masking tape without gumming it all up. So it actually fits straight in without any deburring, although it's got a sharp corner, so I'll need to run it in the little vibratory rumbler or tumbler just to soften the edges before I send it off for anodizing. So I just need to scrape the glue off and run it on a bit of emery paper, and then I can put it in the tumbler or rumbler. Alright, well here's a little bit of progress. So if I put the special tool in the right place, it just lifts straight off. This is going to save a lot of time. So you just place that in the right spot and it just lifts straight off. So the underneath is not really damaged. There's a very slight little chamfer produced of about a thou or so. That's really brilliant. So all it is, a piece of an old power hacksaw blade that I have sharpened with a chisel-like flat on it. Can you see that there? So it's sort of the shape of a thin woodworking chisel. It's not razor sharp. I've softened it with a lap because it doesn't need to be. It's just a very narrow wedge so you can get in under there and wedge the parts off. The good thing about this method with this tool is that it removes the part cleanly off of the masking tape. Well, you know, 98% or something. There's a little bit staying behind, but not very much. And that is a lot quicker than picking all of the masking tape and adhesive off each part. Now I can clean it off a big mounted plate with a scraper, with a painter's scraper, very easily. This is a universal tool. Look at that. So it's just a power hacksaw blade with a 20-degree, approximately 20-degree bevel ground on it, and I've just lapped the very sharp edge off. I don't know if that's important or not, but basically that's one hell of a useful tool. Finally, all you've got left is the masking tape adhesive, and I've just used a bit of methylated spirits. It seems to dissolve it, and it's not too toxic a solvent as far as I know. I'm not a chemist, but I gather methylated spirits is just wood alcohol, something like that. And finally, a little bit of time in the tumbler or rumbler with some abrasive medium just to take the sharp edges off before I send them away for anodizing. So I'm not an expert on finishing, but you know, from a low budget point of view, I'm slowly learning. I might put together a bit of a video on what I've learned so far for other people who are in that situation also. Let's just get those out. So we've got a bunch of these. Some marks there on the underneath, but they seem to be aware of the top surface. Yeah, they look good. Alright, thanks for watching guys. Catch you next time. Cheers.